Morning everybody. Now today we'll be undertaking food in the light of chemistry. Now let us introduce with the logo of American Chemical Society, one of the most popular publication house. So logo is chemistry for life. That means wherever you find any or try to explain something or find anything to explain, then chemistry is there to help you. Now again we share another logo, that is the logo of IFST, the Institute of Food Science and Technology. What is the logo? Is love food, love science. If we amalgamate these two things, then what happens? You can find your food in the light of chemistry. Wherever you find any or try to explain something in the subject of food, then you need to take the help of chemistry. So today's topic is understand your food in the light of chemistry. Now let us start with a popular your operation, that is where the raw material is coming into food industry, that is your milk industry. So milk containers are there, that is refrigerated vans are in the row. They are putting their milk into the industry. So this is the inlet raw material of the milk. And what is the outlet product? That is the packaged milk product, what you are purchasing in the morning. So these are the trays or cartons within which the packaged milk are produced. Now in between these two, in and out, there is another major operation, which you may call it as heart of the operation or heart of the processing plant, that is what is called as control. So if you want to impose a control over the whole process of manufacturing of these milk and milk products, in between, in and out, then you need to take the help of chemistry. That is, you need to analyze the thing, analyze your product, analyze your raw material, analyze the product, intermediate product, so that you can make a quality product. And on that basis, on that data, on that findings, you can control the whole plant. So this is the application of your or the importance of chemistry in a food industry. Now let's start with this figure. So these figures are nothing, these are well-known figures what we have studied since 9-10 science, physical science. The first one is for carbohydrates, second one is for proteins, third one is for fats, fourth one is for vitamins, fifth one is for minerals, salts, and the sixth one is the water. So what do we mean by it? These are the chemistry entities or chemistry figures with it, which is nothing but chemistry. But if we integrate all these things or mix all these things, can't we find another product which is very familiar to us? This is food. So we can find our food in terms of those figures. These are the carbohydrate, protein, fats, minerals, and vitamins. So that is why we have taken this particular topic. You can know your food in light of chemistry. The first example, so if you have a raw egg, and if you go for poaching the egg, then what the changes will happen? The water soluble proteins will get insolubilized. So that is why this thing will be solidified, and the appeal or acceptability to the consumer will be there. So unless and until it is solid, you cannot consume it. So what is the chemistry inside it? The native albumin protein is denatured by the treatment of it, and there will be sulfur linkage, and this way this will be immobilized or insolubilized. So this is again we are explaining our food with the help of chemistry. Now that take another example. Why are curries hot? Why curries are hot? So this is the short answer is capsaicin. The long answer is more of mouthful. This is the structure, organic structure, which is actually responsible for your hotness. The receptors in your mouth and throat can detect even tiny amounts of capsaicin, just 10 parts per million. But so whenever, even another example, banana turns brown because a hormone within them triggers the release of ethylene gas. This acts as a ripening process until the banana becomes overripe. So if you have polyphenol oxidase, so apples and potatoes, if you keep together and leaving your banana next to an apple, will hasten the ripening process because polyphenol oxidase is there. So this way we can explain the different happenings of food through the use of chemistry. Now how to work with flavor? So we like flavor, and our consumer appeal, what we call it as consumer appeal with different food, is actually the flavor profile. So these are different products. These are breads, these are meat, these are drinks, these are chocolate. So these are all liked by people for the flavor of or unique flavor of each and every particle. And where from this flavor is coming? This is nothing but the reaction which is called is Maillard reaction, and lots of other reactions are there where carbohydrates and sugars or proteins or amino acids will be reacting to get you the brown color as well as new flavors. This is a simple look, but if you go for inside it, there will be lots of chemical reactions, complex chemical reactions will be there, through which there are aldol condensation, and this will give you the different aroma and brown color. If we go more details, then these are the different compounds which will be produced during the flavor formation. It is the best class bread crust flavor. Lots of furanols, cyclotin, pyranols are there, furfuranals are there. These are producing combining color. If you go for Amadori rearrangement product, even that is producing meat flavor. So lots of chemical reactions are there. So thousands of flavor molecules are producing, they are reacting through different chemical reactions and producing different colors and flavor compounds. This way again they explains the Amadori compound. Then lots of compounds, pyrazines, pyraroles, furanones, furans. So these are contributing the unique flavors to different food product. Soybean processing and MRPs formation, Maillard reaction products formation, Maillard products and milk processing, pasta processing and Maillard reaction products. So Maillard reaction products are everywhere, even meat processing and coffee bean processing. Even cooking with wine. So if you go for your if you use a wine for the preparation of some culinary preparation, then you can get flavors because sugars are there and even amino acids and proteins are there in your cooking preparation. So amino acid reducing here will caramelize the carbohydrate and you get the respective flavor. And this way poor wine which has high amount of sugar, residual sugar still present in the wine, that is less fermentation has been done, so lots of carbohydrates will be, the sugars will be there, and that will be reacting with amino acids giving you good flavor products. So if you go for designing a product which will be very very light in weight, which will be very crispy, which will be very high water absorption index and crunchy, how can we get it? So again these are the pictures. So these are looking like plastics and it is looking like so. This is very well known picture. This is an extruded product. So kurkure we generally consume. So through the use of polymeric science we can explain or we can produce or design our products which will be very much porous. So that is why this will low bulk density product, crispiness will be there, and the low moisture product, so that will be can be preserved. And through how we can develop it? Through the use of extruders. So this is simple and Archimedean screw which is rotating inside the static sleeve or barrel, and thus producing high shear environment. In turn, that will be producing high temperature and high pressure environment. So within that atmosphere, all the reactions like zitrination, denaturation, so intercomponents reactions will be happening, and the material will be cooked from solid mass. This will be liquefied mass, and as soon as it will be exit from the die head, so it will be again solidified and it will be cooled down to normal temperature, and this way there will be flash evaporation will be happening, and the perforated product you will get. So this way you can, so ultimately there will be lots of chemical reaction which will be happening within this particular high shear, high pressure, high temperature environment. You can get sterile and crunchy product. So again we go for the next question, how to make your food surface a bit greasy. If you have a bread and if you want to make a very thin film of fat over your bread with the help of your spoon, then how to do it? You should have a plasticized mass of fat. So how to get it? You have oil. How to get your plastic mass or greasy fat? So that is again with the help of chemistry we can get it. Unsaturated oil if you have, then if you have partial hydrogenation or hydrogenation of that oil, you get saturated fat. But in between these two, you can get a mass which will be plasticide or semi-solid. In this way, oleic acid, unsaturated acid, can be saturated to stearic acid. So, but that will again produce trans fatty acid, which will be nutritionally not so good. So, you have to have some idea how to control the hydrogenation, how to get your less amount of trans fat, and in what way you can control the melting point of your fat. So this way you can produce or design your food, the consistency or texture of your food material, fat material. So next question, what protocol should you follow to reject urea milk? Again, if you go for analysis, how to get chemistry to explain the thing. If you have a urea in milk, adulterated milk is adulterated with urea, then very easily you can identify whether the urea is indeed added or not. Soybean powder, you know, it contains urease enzyme, and urease will break down urea into ammonia, and with the help of litmus paper you can easily detect whether urea is present or not. So again chemistry will help you. Which makes bread slice tender but not collapsible? You have bread slices, lots of small cubes are there which are hollow cubes. So there is again the chemistry, protein chemistry, fat as well as water, how carbon dioxide will be produced by the fermentation by microorganism, and how they will escape, leaving behind lots of pores inside, and how the rigidity and the texture will be maintained depending on the lipids, depending on the proteins, depending on the amount of gases formed, and depending on the strength of the dough. So this way ultimately through the proofing step you can control the porosity as well the mechanical rigidity of your bread. So again if we go for our next question, which makes ice cream so appealing? Ice cream has solid state, air state as well as liquid state. So lots of water is there, sugar is there, proteins are there, fat is there. So structural element is ice crystal, air bubbles, fat and serum phase. So you know that there is again the scope of chemistry to explain the different coexistence of different phases and stability of ice cream. So ice crystallization is there, physical chemistry, lots of contribution is there, size distribution, heat transfer, ripening is there. So how to make your ice cream more smoother? Even this is the same picture of your ice cream. So you need to take the help of chemistry. And the last question, how can we avoid calorie with cream? Even you are consuming calorie